In this video, we will take a look at how to write a program for recursion. Let's take the same example as the previous video of finding the factorial. So my function is going to be named FACT. I'm going to take some number as my input parameter for which I want to find the factorial, and I'm going to return an integer because I want to return the factorial of the number. So what have we said in the previous video? We said that the factorial of any number n, the solution is going to be n into the factorial of n minus 1. We said that this will be the solution. So of course we must return the solution. Now we go on doing this until a point when this problem becomes so simple that we directly give an answer without making another function call. So what was that condition? We said that if n is equal to 0, we say that the solution is 1. So when we had to calculate 0 factorial, we said that the solution was 1. So of course we want to return the solution. So this is it. That's all the code is for recursion. As you can see, this is a code for finding the factorial. What am I returning? I'm going to return n into the factorial of n minus 1. This is the same thing we have seen in our previous video. Now, when the solution size becomes so small that it reaches 0, and we have to find the factorial of 0, we can give the direct answer without having to make another function call. We know that 0 factorial is 1. So when we say factorial of 0, we are going to just directly be returned 1. As you can see, inside the function fact itself, we are calling the same function. So you can also see in this example where the function is calling itself. So now that we have seen how to write the code, let's see how the output actually is generated. So first, let's say I want to calculate factorial of 3. So I want to calculate factorial of 3. I'm going to give a box to this function call. So what does this function call do? N is equal to 3, it's not equal to 0, so we don't go through this line of code. What do we have to return? We have to return n into factorial of n minus 1. So what do we have to return? We are returning 3 into factorial, let me write that in a different color, 3 into factorial of 2. Right. Now when we write this line, we automatically go into the block of factorial of 2. So now factorial of 2 has been called. What happens in factorial of 2? 2 is not equal to 0. We don't execute this statement. We have to return 2 into factorial of 1. Now factorial of 1 has been called. Let's go to that block. What happens in factorial of 1? 1 is not equal to 0, so we have to return 1 into factorial of 0. Now the function has been called for factorial of 0. Let's go to that block. So I have factorial of 0. What must I return? I have to return 1 because n is equal to 0. So now I return 1. So when I return from factorial of 0, I have to return this value to the point at which factorial of 0 was called. So factorial of 0 was called from here. This function is done executing and I will replace it with its return value. So now factorial of 1 must return 1 into 1. So what does this return? This returns 1. Okay, so factorial of 1 will provide its return value at the time when it was called. Factorial of 1 was called over here. So it will replace the function call with its return value. So now factorial of 2 is 2 into 1. This is equal to 2. So now factorial of 2 will return its value to the point at which it was called. Factorial of 2 was called here. So it's going to replace its call with its return value. So now factorial of 3 is equal to 3 into 2, which is equal to 3. Now factorial of 3 will return its return value to the point at which it was called. That means since the user has called factorial of 3, this will be returned back to the user. I'm sorry, this is not 3, this is 6. Right. So it will return 6 back to the user and thereby returning to the user the factorial of 3, which is exactly what we want. So this is how a recursive function works, and this is how you can see what are the dynamics of generating the output as well.